Hello everyone, welcome back to another new video. In this video, we have important problems of slope deflection method, and this question is asked in 2080 spring in final examination. So such type of question is repeatedly asking. So this will be very important for our examination. So first read the question. Analyze the continuous beam as shown in the figure by the slope deflection methods. Support is rotated by 150-degree anti-clockwise. This is anti-clockwise, so we need to take negative. So minus theta E will be minus 150. And for the conversion of degree into radian, multiply by pi by 180, we get this value. This is in radian. Okay. And support D and C sink by 10 mm and 5 mm. Delta D is 10 mm sink, it means down. So downward, and C 5 mm downward, so this will be downward, and the value of EI is given over here 30 into 10 power 11. So this value, this is Newton meter mm square, so we need to change this into meter square. So for Newton we need to divide by 1000, then this will be in kilonewton, and this is in mm square. So also we need to divide by 1000. This will be in meter, but we have a square, so we need to do a square. So this will be in kilonewton meter square, and our value will be this much. Okay, and you can see we have a given moment 30 kilonewton meter at A. E is fixed support. Okay, and B, C, D are nodal support, and these are the intermediate supports. And UDL of 10 kilonewton is acting for the BC, and 50 kN point load at the center of this DC beam. Okay, DC span, these are the given in the question. Now, as we know, for the any slope deflection problem, we need to follow three different steps. Okay, so in very first we have calculation of fixing moment. You can see over here, calculation of fixing moment, and in second step slope deflection equation, and in third step moment calculation. So any problem we will solve in three different steps. So let's see the first step. So calculate the moment for the all the section. For the fixing moment for the B to A. B to A, this will be our, look here, our in the question already 30 kilometer meter moment is given at a point A. So this is anti-clockwise. So anti-clockwise is negative. So minus 30. Okay, we don't need to take balance moment. We need to take only balance moment for the point load. Okay, if we have given already moment at the in support, we don't need to balance, we need to take as usual. Okay, and for the B to C, this is UDL, so formula is WL square by 12. So W10 L3 and 12 we get minus 7.5. From left to right, B to C we are left to right, so negative, and for C to B, right to left, positive value, and C to D, here no any load, so 0, and D to C is also 0, and for D to E, this is acting at the center of this D, so minus WL by 8, so minus W means 15, L 4, 8, this value will be minus 7.5, and for right to left, this value will be just plus, so positive 7.5 kilometer meter. Now let's move to the another step, that is slope deflection equation. Okay, and this slope deflection equation will be very important. Okay, now all the funda belongs to this slope deflection, so this listen carefully, and before going to this I will share one important information for you. Okay, so we are going to start a 15 days crash course. Okay, on that crash course you can see over here our 15 days crash course will be uh, started, okay, very soon. So if you are interested, then you can go in the description box. I will keep there all the links, okay, and from there you can get WhatsApp group link and link in, uh, and from there you can get all the important formula, important concept related uh, video, okay. So from there you can get all the informative content and you can get all the access, okay. So please do visit our groups, okay. So and if you want to join final examination fast track revision, then you can contact in the given number, okay. So please contact, okay. Now our second step is slope reflection equation. So for this we need to just write the slope deflection equation in very first. So our slope deflection equation for MB to C is, for B to C is our equation m fixed in moment for B to C plus 2 EI upon L 2 theta B plus theta C minus 3 delta upon L. This is our standard slope deflection equations. So the value of 2 EI, the value of EI is given 2. So we need to take 2 into 2 means 4 EI plus 2 theta B, 2 theta B plus 2 theta C minus 3 delta. The value of delta is 3 into 10 to the power 3, 5 into 10 minus 3 by 3. We get this equations number 1. Similarly, for C to B equations is same. Okay, we just need to change uh, 2 times theta C and here 2 times theta B. So in first letter for the C to B we need to multiply C 2 times and B as a single. So we get second equations. And for C to D, okay, for C to D we have a given deflection 5 mm. So delta will be taken. Okay, so this value becomes, and for regarding this value delta, this is plus, or when we take positive value or very negative. So we need to consider this value. We have a uh, two different support, and if beam will deflect like this in this equation 10 mm sink, it means this B moves over here B dash. So from B dash to, if we look left side, so you can see this we have to look upward. So when we look upward, we have to take positive value, and when we look downward, we have to take the negative value. If suppose this will be also settle down by 20 mm, then we need to look downward. In this case, we need to take delta negative. Okay, only this much, and the value is taken with respect to this point. Okay, how much up or down respect to this point. So keep in mind always. Okay, so similarly for C to D, our fixed moment 0, so 2 EI by L. In the place of EI, the value of 3 EI, so this will be 6, and 2 theta B plus theta D minus 3 delta. The value of delta is this, and our this will be third equations. And for D to C, first letter is D, so we need to multiply 2 theta D and C, and finally we get this equation. Okay, so this we have completed uh, this span. Now for the D to E, fixed moment for D to E is 7.5, and the value of EI is given 4. So 4 into EI means 8 EI by 4. Okay, and the value of this theta E is given in the equation, that is anti-clockwise, so we will take a minus value, and this delta is 0.01, and finally this will be our fifth equation. Similarly E to D, okay, E to D theta E is given this value, and final we get this much value. Okay, so this is our second step, and in third step is equilibrium condition. Okay, so for the equilibrium condition we need to, you can see in the figure, we have three different intermediate support, so we need to take three different equations. Okay, for D point, DE plus DC equal to 0. For C, CD plus CB equal to 0. For B, BA plus BC equal to 0. So apply this equilibrium condition. Okay, so for B, as I said, BA plus BC equal to 0. So we have calculated the value of BA, that is 30, and for the BC we have also equation, so we just put, and this value will be 7. And for joint C we have CB plus CD, so the value of CB we have already calculated, and CB also we have already calculated CD, so finally we get this value. And for D, DC plus D equal to 0, and for DC moment we have calculated this value, and for DE this value, and then we get 9 equation. And solving 7, 8 and 9, we get theta B, theta C and theta D. And now we need to replace all these value in the slope deflection equation, that is in step number 2. Okay, so from these all equations here, from these equations, from equation 1, 2, 3 and 4, 5, 6, we get all the moment value. If you put these all the values in the given above equations, so we need to put these all the values in the given slope deflection equation, and then finally we get 30 kilometer in BA, BC minus 30, CB minus 2.2, CD minus 2.3, DC 1.36, and DE 1.4, and ED 12.45. So this all value we got. Now for the bending moment, we have to always follow this rule. In very first, you need to draw this line, this, and if we are looking left to right, then negative, positive. This will be our sign convention rule. So if you look from left to right, and the value is negative, so we have to take this value as the upper part of this beam portion. Okay. Okay. So we have to just follow this sign convention rule. Okay. Minus, plus, plus, minus. So you can see here B to A. Okay, B to A we are from right to left, so it means this value will be positive, value will be upward. So this is 30, so upward 30 is over here at the B. Okay, and for B to C you can see minus 30. So B to C means we are uh, from left to right, so negative value will be upward, so B to C will be minus 30, so this will be upward. And C to B, and C to B we are moving from right to left, so you can see here right to left we have to take positive value upward. So C to B means upward plus positive value upward, and minus value is downward. It means this is our, for the C to B we are looking right to left, and this is minus value, so minus value will be downward. Look here, this is our beam, so from here negative will be downward, positive will be upward, so that's why we will take this value downward, keep in mind. And C to D minus 2.43. Okay, similarly 1.3, this is for the D to E, D to C means D to C, right to left. Okay, and for the right to left you can see here positive will be upward, negative will be downward. This is positive, so we need to take the upward value, that is 1.36, only this means. Okay, and again for the E to D, E to D, E to D means right to left, so right to left positive will be up, negative down. This will be positive value, so will be up, this is here. And if this will be minus, then we have to take the negative values downward. Okay, so after this we got this value over here. Okay, now we need to take two different things. Okay, either uh, for the span B to C. This is B to C. We have UDL. So for the UDL, this will be maximum, and this will be WLSY by S. So we'll be get 11.25. And for the point load, that is for the D to C, we have point load is acting at the middle portion. So this will be W. Normally we need to apply the PAB by L. Okay, so you can just take this value PAB by L. From here to here is A2 and 2. The value of L will be total 2 plus 2 4, and P means the load is acting. So you get 5. And you can also apply this WL by 4. So, so this will be 15. And all the values from this calculated moment, upper part of this will be positive, and below of this all the calculated value will be our negative value. Okay, only this much change, and we have to write positive and negative. Okay, above than this value like this portion and this portion will be positive. Okay, and from downward this also positive, and all of the value will be negative. Okay, I hope you got the solution. Thanks for watching. Thank you so much. Please do like, share, and subscribe the channel.